Hi, and welcome to the last section of um, encryption for essentially for P4 for Part B of IT system security. Um, so this is going to be covering basically applications of um, cryptography and what they can be used in, and sort of how they're used to encrypt data and keep things safe. So this P4 has quite a lot of parts to it. So it's about the principles, what types of encryption there are, and then the applications of said encryption. So there's quite a bit to talk about. It's quite a big pass criteria, and it will also link into other parts as well. So this will also lead on to how this sort of stuff can affect um, a business as well. How can this impact on a business, which is, I believe, part of your distinction task. So, without further ado, I'll get on with it, and I'll talk a little bit more about merits and distinctions later on. So, um, this is the last thing. So, applications of cryptography. Now, essentially, what we're going to talk about is different applications. Some things about digital keys and certificates, sort of mainly, and then a little bit on transport methods. So how data is transferred between one computer and another. So how is that encrypted? As in when there's a connection already established. So before the connection is established, before you start sending data, how do they establish this connection? So we'll be talking about that as well. So what I'm going to start off with is digital keys. So digital keys are usually used for symmetric and asymmetric encryption, which is what I mentioned before in previous videos. Symmetric key encryption is what I'm going to talk about first. So basically, that's used for, well, there's a key that's generated for a piece of data which is used to encrypt it. Now, the key encrypts the data, but is also obviously used to decrypt the data, hence why it's called a key, because it basically locks it and unlocks it. What the key does is it's got the algorithm inside of it on how to change it from, say, like a line of text into jumbled up encrypted message. And obviously you just run the same thing through the key again and it'll revert it back. So that's why it's used to encrypt and decrypt. And usually it's used for local devices, because obviously if you're going through local devices, there shouldn't be anybody really on the network looking in, and even if there is, and for whatever reason something doesn't get sent, obviously your admin's going to pick it up and stuff like that. But obviously it's not completely lost because obviously you've got an encryption on it, so it's better used for them sort of uses anyway. So obviously, if you're going to send it over the internet and somebody does intercept it, if they intercept the piece of data and the key, obviously then that means they can decrypt it, which is no good. There has been concepts thrown around where obviously you could send the data and then a key another point. So if any of them get lost, then it doesn't really matter, because with the if somebody steals the encryption key but not the data, then they can't really do much about that, and vice versa. If they steal the data and they don't have the encryption key, again, they can't do anything about that. But usually, obviously, you send them together. So you can send them separate, but obviously, because you want things to be quick, you tend to send them both at the same time. Asymmetric encryption, however, which I'm going to go over, uses keys that are mathematically paired. So they're not. It's not the same key to encrypt and decrypt it, but uses something called Diffie-Hellman exchange, which I'm going to go over, I think, in another video, which is a very clever way of doing it. So it basically means that you can send data to one person to another, but the people that are sending data between each other have to have private keys that are mathematically related in some way, so they can encrypt and then decrypt, and you'll see how it works. Symmetric encryption is this, so you literally just have a symmetric key that encrypts a piece of text or a file or whatever, and then use the same key for decryption. However, with asymmetric encryption, like I said, you've got sets of keys, and you do have something called a public key, and I'll go into why you need a public key in order to encrypt and decrypt as well. It is part of the whole process with asymmetric encryption. So that's a quick look at digital keys. So digital keys are just used for encrypting and decrypting things, and obviously you need them in order to get the file back to where it was, because without them, it's going to be impossible to crack unless using some sort of algorithm that's really poorly optimized. Then obviously it would be able to be cracked. But yeah, that's digital keys. And in some other videos, I'm going to be going over encryption in terms of connections, and also encryption in terms of asymmetric encryption and stuff like that. So look out for those. But if anybody's got any questions, let me know. But that's basically introduction into digital keys.